Hi, Geometry. This is our Unit 4, Lesson 4 half sheet notes, and this is page 3. On this page, we're going to talk about how to use our trig to find missing angles of our triangle, and we're going to be talking about using our inverse functions. So previously, we used sine, cosine, and tangent um, functions to find missing sides, and we were given the angle measure. But when we want the angle, when the angle is what we don't know, we're going to use sine inverse, cosine inverse, and tangent inverse. Note that this is like a little -1 exponent, but it's not an exponent. It's just written up above and small. This is the inverse function. So don't say sine to the -1 because that's different. That is something that you'll use later, but this is sine inverse. And on our calculators, you'll notice that there's a sine inverse above sine, a cosine inverse above cosine, and a tangent inverse above tangent. So the steps are exactly the same as finding sides. First, we locate our missing angle, what we want to try to find. We label the sides opposite, adjacent, and hypotenuse in relationship to this angle. We determine whether we want to use sine, cosine, or tangent. So don't forget our SOHCAHTOA, which is so helpful for that step. And then we're going to solve, and this time we're going to be using the inverse button on our calculator. And at the end, you found an angle. So don't forget to tack on a degree symbol. So let's look at this example. We want to find the measure of angle T. So let's go mark T. This is step 1. That's the angle I want to find. And this is my side opposite, the 29. My side adjacent is touching it. And my hypotenuse is also touching it, but the hypotenuse is across from the right angle and is my longest side. So step 3, it looks like I don't know the adjacent side. So I want a trig function that uses opposite and hypotenuse. So opposite and hypotenuse is my sine function. So let's write sine. Now this is where I need a variable. You can use t, you can use theta, you can use x, you can use y. You can really use anything that you would like for your variable. I'm just going to use t for right now since that's the angle I'm trying to find. And the sine of t is equal to the opposite, which is 29, over the adjacent, which is 34. So now this is a little different. I need to cancel this sign right here. I want to solve for just t. So the way we do this, we don't divide by it. The way we do this is we're going to do the inverse sign of both sides. So let's put this in parentheses and put an inverse sign in front of it. And if we do something to the left side, we have to do it to the right side and put an inverse sign in front of it. My sine inverse and my sine cancel each other out. And I get just t on the left side. On the right side, I have sine inverse of 29 over 34. Just a quick side note. This is similar to, if I could flip this over, when we were doing Pythagorean theorem and we get x squared equals 9 and we want to solve for x, we would take the square root of both sides. The square root would cancel my square and I'd get x equals 3. That's exactly what we're doing to cancel sine. We're taking the sine inverse of both sides. We're not multiplying by it. We're not dividing it. We're taking the sine inverse, and that cancels my sine. So now how do I enter this on the calculator? It depends on which calculator you're using. If you're using this style or your phone, you're going to have to divide your numbers first. So 29 divided by 34, really important, equals. And now I want to do sine inverse. It's in green above sine, so let's touch our second button and then the sine button, and I'm going to get 58.53. So my angle T is equal to 58.5 or 58.53 degrees. What about using the other calculator? Well, this style of calculator, I have to touch the sine inverse key first. It's also above the sign, so I'm going to use the light blue button and touch sine. Notice that it opens the parentheses. This is now where I put my numbers, 39, I'm sorry, it's 29. 29 divided by 34, parentheses, and I get that same 58.53. If you're getting a strange number, make sure you're in degree mode, not radians. So let's look at two more examples of this. So let's take a look at number 1 right here. Number 1, it wants us to find again the measure of angle T. So let's go find that and mark it. This is the angle I'm going to work with. This time I'm going to put a theta here. It's a circle with a line in the middle. It's a Greek letter, and a lot of times it's used for angles. So why don't we just use it here as my variable so that you get experience with that. So step 2, let's label my triangle. Well, the 87 is the hypotenuse. The RS, this is my opposite, and the 34 is my adjacent. It touches my angle. So I don't know the opposite side, so I need a trig function that works with adjacent hypotenuse. Using my SOHCAHTOA, I realize that that's cosine. So let's write cosine of this time theta, but you could leave it t or you could make it x. It doesn't matter, it's my variable, equals adjacent over hypotenuse. So now I'm going to do cosine inverse of both sides. When I do that, my cosine cancels. So cosine inverse of my left side, cosine inverse of my right side, and my cosine cancels. And I'm left with theta equals cosine inverse of 34 over 87. Sorry, my 87 doesn't look very good. Let me switch this up. 87, a little bit better. So grab out your calculator, whichever one you're using. On this one, I have to do the 34 divided by 87 first. And then I do my inverse cosine by hitting the green button first. And I have 66.995. So my preference for our class is for you to write that this is 66.9 or 99. If you wrote 67 for this, I wouldn't count it wrong, but I don't particularly like rounding to whole numbers. I don't think it's a good habit to get into. So try number 2 and check your answer in our folder. But let's jump down to number 4. Number 4 says approximate angle A if the ratio of the adjacent divided by the hypotenuse is means equals 0.54. So they're saying that the adjacent divided by the hypotenuse is equal to 0.54. What? Oh, using our SOHCAHTOA, adjacent divided by the hypotenuse would be the cosine of my angle. The cosine of angle A is equal to this. So let's write that equation. The cosine of angle A is equal to 0.54. So if I want to find angle A, I need to cancel my cosine. That means I'm going to do cosine inverse of both sides. You can just go ahead and write this as cosine inverse of 0.54. So now I know to find angle A, I have to do cosine inverse of 0.54. Let's do this on our calculators. So 0.54, and I do cosine inverse, and I see that I have 57.3 degrees. Thank you so much.